So welcome everyone to this very interesting lecture we have planned for today. So for those who don't know me, so I'm Alexander Lokman. I'm Associate Professor at the Institute of Psychology. And it's my absolute pleasure to introduce Professor Lupiáñez today. He'll be giving a very interesting talk. So he's an international expert on the topic of executive functions. So that encompasses a lot, not just attention and attentional control. Yeah, so he's an international expert on the topic. He's the head of the Cognitive Neuroscience Research Group at the University of Granada, and today he will be presenting a very interesting presentation on attention, attentional control, and components of vigilance in the context of a novel and yeah, very elaborate paradigm called the ANTI-Vea. So thank you very much for accepting the invite, and yeah, the floor is all yours.
Thank you. Yeah, first of all, thank you very much for the invitation. It's a pleasure for me, and meeting some people that I knew. I didn't know that actually somebody from here was in Erasmus. So I hope you are not get bored, because some of the thing I'm going to present was things that we were teaching in the course, in the master course I teach. So today, I'm going to try to give you an overview. I hope it's not longer than 1 hour, that what I were expected to the talk to last. And I will see, for me, attention is like a 3 attentional function and 2 sources of control. I will later explain. And then I will explain, as Alexander said, the paradigm we have developed to measure attention, like the ANTI-Vea task. And with that paradigm, I will try to understand how we can work with this paradigm to understand why we decrement our attention across time on task. What is the vigilant? Why is the vigilant decrement? And we will distinguish between 2 aspects of vigilance. Then I will give you 2 examples of 2 studies we have done with the ANTI-Vea task. One is a lab study, trying to see how electrical stimulation can improve attention, and the decrement can mitigate the decrement in vigilance. And another one is going to be a sleep deprivation online study. We did a sleep deprivation study, but participants were at home. That was interesting. And then we will finish with some conclusion. Okay. First, let's start with what I think is attention. And then if we do a historical overview, then yeah, you may have heard about this famous sentence of William James that everybody knows what attention is. And yeah, if you ask anybody, people use this term, attention. Pay attention, don't pay attention, you were not paying attention. So everybody have a naive idea. And then that's what William James said. But then if we go more deeply into what attention is, then we have to consider several models of attention in which attention have considered differently. For example, in Broadbent model of attention is like a filter. So we receive a lot of information, and somewhere there is a filter in which only one piece of information goes through higher cognitive processing, so that we are only aware, or we will only remember part of the information we receive. And that led for decades of research. But not everything could be explained. And other model, like Kahneman model, like Kahneman sadly passed away recently, but he had been very influential in general in psychology, and especially in attention. He published in the 70s a book entitled Attention and Effort, and that's what he emphasized in attention. Attention is as energy. So for him, attention had to do with how many capacity we have in a given moment, how much aroused we are, and this capacity had to be distributed among the different tasks. So he highlighted the idea of attention as resources, attention as attention energy that had to be distributed among different tasks. But actually, the fact that we can do several different things at the same time, but only one, we focus only one, how we select this thing we want to do on every time was for Norman and Chalice, the main problem of selection, selecting what to do at every time. So attentional control. So as you can see, different people, different models have emphasized different aspects of attention. Then we can summarize, or the way I consider, attention is not only one of these, maybe attention is everything. Attention is a problem of selection, but selection, early selection, that had to say with selection in perception, how we select the input, which information receive more attention, which one is more given priority in the system. But however, also attention is a problem of arousal or capacity, where, how much capacity we have and how we spread this capacity among the different possibilities we have. And another problem is the problem of control, how we can do what will give us a future reward, or in contrast, behave automatically and receive the immediate reward, but not long term. So these are the three problems of attention. If we can summarize in these three aspects, the different model of attention. That leads some people to say, well, maybe if attention is everything, maybe no one knows what attention is. We will have to rephrase the sentence. And actually he said, no one knows what attention is. This is Bernard Hummel. He's a very influential, important person in attention. And he said, we challenge the usefulness of attention as a unitary construct or a neural system. The concept has too many things to justify a single term. So basically he said, if attention is so many things, we don't care about attention. Let's speak about every single thing that attention is, rather than just trying to understand the global. This is one possibility. Another possibility is what very recently Wu said, yes, we know what attention is. Maybe if you ask for a definition, we don't know, there's so many things, but people do research on attention. So he said more a data-driven approach, and then basically he said, a specific functional conception of attention is incorporated into the task that people use in a standard experimental paradigm. So people design paradigm to research attention, to investigate attention. So we know what attention is. And then basically at the end he do a critical analysis. He said, well, attention is when we pay attention to a target, as we study in science, the subject of is how we select this target to perform a task, that attention. So attention had to do with selection. So this is the problem. But then this is not a simple question. There are different processes to explain attention. And that's why we need a conceptual integration of the different models we have seen before. And one example, and it's the one we follow, is the idea of Michael Posner, who said, well, attention maybe had to do with selection, but had to do with selection with different function, different mechanism. They are integrated, and it's good that we have a mechanism called attention, because that's what gives unity to the system. We use different mechanism for pursuing a goal, but we have a goal, and then all the mechanism within attention have to be orchestrated to pursue that goal. According to him, then there is he said that there are three basic concepts about attention. One thing is that attention is different from processing. Attention is a mechanism modulating processing, but processing is something different. Attention is a modulator. It's not or memory. Memory have a function. Attention can modulate memory, can modulate action, can modulate perception, but attention in itself is a different mechanism. And attention, there is not one single region where we can localize attention. Attention is spread in different in different regions, in different network. They have different anatomical regions, all together working as a system, giving the neural structure for the function of attention. And also they said that also attention is not a single function. There are 7 different functions that had to do with attention. And then he said, I mean, typically he called this function orienting, alerting, and executive function. He described the different brain structures, different neurotransmitter involved in the different functions. More recently, in their paper in 2012, he said, well, there is a system having to do with starting with the locus coeruleus projection of norepinephrine to especially the right parietal and frontal hemisphere, and that's the basis for alertness. Whereas the frontoparietal, dorsal, and ventral network could be the basis for orienting of attention, and the different, other different brain region involving mainly the prefrontal cortex and prefrontal and parietal cortex. I mean, he distinguished two different regions, like frontoparietal control system and the cingulopercular system. There are different circuits involving the prefrontal cortex are involved in attentional control or cognitive control, okay? So then we can summarize, okay, attention is a system organized in different subsystems with three functions. And the three functions have to do with selection. When we say alertness, alertness is selecting in time. So when we have a warning cue, help us to select the now. Or if I give you ready, set, and then you get ready for a moment later. So attention has to do with selecting in time, and that's what we call alertness or temporal orienting. But also selection can be selection in perception. So among all the information that reach our senses, we can select part of the information. And that's what he called orienting. That's what I would say, this selection in the input. And also, we can receive a lot of information. We can process more information than the one we respond to. So there is another selection that has to do with action. We can receive many information, but then we have to decide what to do. Should I do this thing that will give me an immediate reward, or should I avoid doing that and doing something else that will not give me any reinforcement now, but will give me a goal, I will achieve my goal tomorrow, or in 1 year, or in 10 years. So selection for action and cognitive control have to do with selecting which action to perform for achieving a future goal. So these are, to me, the three functions of selection, all of them having to do with different aspects of selection. So attention is selection at different levels. And also I think another important aspect of attention is that attention can be allocated automatically and voluntarily. So this is an image from Mauricio Corbetta. He said that imagine you are focusing here when you are in the library or you are in your lab working. You can somehow select the source of information you are focusing. You are reading the paper for the discussion tomorrow, and you are concentrated here, and that's what you are doing because you are motivated. Maybe you would like to go for a beer with friends, but you are somehow ignoring that and focusing on your goal now. But if your friend calls you and say, hey, let's go for, and then in this moment, automatically, this source of information will interrupt and will cut your attention. So that's what he said, that there is two ways of attending. One is more voluntary, goal-driven, and the other one is more involuntary, more stimulus-driven. So then we can complete our schema saying that, well, and there is very well delineated the two systems for maintaining attention and attending voluntarily, and another system that Mauricio Corbetta called like an interrupter, like another system that kick in and change whatever you are attending to another object or another aspect. And then we can complete what I think is attention, what I call three attentional functions had to do with selection in time or alertness, selecting in perception and the input, orienting, and selection in the output, or selection for action, cognitive control, and two ways of exerting this function. One more voluntary, top-down control, and one more involuntary, stimulus-driven. Okay, so that, for me, understanding attention, yes, attention is not a single thing, but attention, we can understand and investigate attention considering that this is not a single mechanism, it's a complex mechanism involving different functions, working in different modes, but we can investigate that. Okay, so that's be my idea. When I think of attention, that's what I think, what I have in mind that attention, and that's what maybe you got the idea that from the course that I say many times, that's attention, we emphasize this. But then there's one aspect that we have not touched, is that typically, okay, we can attend, but we cannot attend for a long time. When we have to do, for example, a lecture, it's very typical that when you are after a few minutes, then your mind goes somewhere else. It's difficult to pay attention for a long period of time. That's what we call vigilance. So let's see how we can measure attention and maintenance of attention. So I guess nowadays you all know this task, the attentional network test task developed by the Posner group. In the 2002, they developed a task which had become very famous and very well used for investigating attention with this logic. Basically, you have to respond to the center arrow, ignore the flanker arrows, and the flanker arrow sometimes is congruent, sometimes is congruent, and then you can measure cognitive control. And then there is, the arrows are preceded by either a peripheral cue, exactly where the target will appear, and then by comparing where the cue tell you where the target will appear with a condition when there is no cueing, then you can compare orienting, and sometimes you have two asterisks alerting you but not telling you where, but by comparing this condition with this one, then you can measure alertness. More at the same time, a little bit later, we developed we were interested not only in investigating the three attentional functions, but how they work together. And then we developed the ANTI-task, which is the attention network test, and the interaction, in which we, in fun task, we compare congruent and incongruent arrows for measuring cognitive control, but then we use different variables for the different network. So in half of the trial, we have a tone, a beep at the beginning that warn you for be ready for the target. Some of the time you have a tone, sometimes you don't have it. By comparing this, you measure alertness. And the asterisk is always sometimes presented, which can be at the same location or the opposite. And then we have valid and invalid trial. By comparing these two, we measure orienting. And as I said, these tasks have been used for many years. Either of these two tasks have been many times. I said 700 papers, probably nowadays is 800 or 900. Here, if you are interested, this paper by Raymond Klein Group is a very good review, recent review about the development of this family of tasks. This other version is very interesting. And there's been a lot of papers using this task for measuring attention in different populations. And have been used for measuring attention in children, in elderly, with ADHD, fibromyalgia, multiple sclerosis, Alzheimer's disease, anxiety, schizophrenia, many populations. And especially when you work with population, the problem is that, especially if you have a brain damage or something like that, patient might have not only problem in attention, they have a general problem in which they have less vigilance. They cannot maintain their attention for a long time. And then the question is that could be maybe some of these deficits that have been explained as a deficit in attention or deficit in any performance in any test. They might do a memory test that they will do worse as well. But it's not because they have a memory deficit, because they have a problem in maintaining their level of activation for some period of time. So we thought it is important to consider also vigilance, because any deficit in vigilance, if you have low vigilance, you do worse everything. So we thought it would be important to add a measure of vigilance. Vigilance has been investigated especially in the applied field, like for example, showing that doctors might have some more problem when they do work for extensive period of time. That have been lead to important problems. Also in driving. Many of the problem in driving is for driving for too long. That's why people say, no, it's important not to drive for more than 2 hours. You have to relax and then charge. People say, charge the batteries. Then you will see that when you say you have to relax and charge the batteries, we have considering like an energetic theory of attention, as if attention are like gasoline or energy like the batteries. Or for example, in airplane controllers, or for example, in the scanner, in the safety in the airport, people in security system. So everybody assumes that vigilance is very important to measure that. And people have used typically very simple tasks for measuring vigilance. Like for example, this is the psychomotor vigilance test. And basically here you have for example, you have a clock, start filling of red everything, and then you have to stop as soon as possible. Simply you have to respond as quickly as possible. You are measuring how fast you can react. Or you can start with a number, starting 1,000, the number goes down, you have to stop the number, the down counter as fast as possible. With this kind of task, you can measure like how vigilant you are in order to detect or react immediately to the environment. There are other tasks in which, rather than measuring how fast you are reacting to the environment, is how vigilant you are to notice small changes in the environment. It's a different aspect. So basically, this is one of the famous is multi-word clock task. This is like, imagine that you have like a needle clock going one by one, jumping from one to the next. Very boring task. And you only have to tell me when sometime the dot jumped 2 slots instead of 1. And that's it's very easy because it's a very simple task. But the thing is that when people are doing the task, they get bored and then they miss a lot of those trials. But in this case, I'm not asking you to be very fast, simply detecting. Be vigilant and tell me when you realize something. Or for example, in another task which is called the SART, which I give you one number and you have to respond as quickly as possible to that number, to any number but number 3, for example. You are responding, it's a single number. We know very well. But then you are responding quickly to the numbers, and what happens is that sometimes you will get the number 3 and you respond as well. So with this task, we think we measure something different, a different aspect of vigilance. So with this PVT task, what we call we measure what we call arousal vigilance, which is the tonic arousal level. So, and typically what we find is that responses to the target, in this case, increase across minute or across time. And the time become also more variable. So, and sleep deprivation is very sensitive to this. Here you have people who are deprived, sleep deprived, their decrement is much larger. So this task measures our level of arousal. Across time, apparently arousal is reduced, especially if we have sleep deprived. Whereas in this case, what this measure is what we call executive vigilance. Basically, executive vigilance will be a decline over time of the detection rate of infrequent but critical trial. So here you don't have to respond quickly, simply to notice. It's important to notice something is very infrequent, not happen very regularly, but it's very important that you notice this, because that means that you have to do something else. And what happens typically is that the hit rate, the number of time that we detect the critical event decrease with time, okay? So we thought that it would be nice to have a measure of attention, the 3 function, and vigilance, and distinguish between these 2 aspects of vigilance. And that's what that's why we developed the ANTI-Vea task. It took us several years proving, I mean, I'm telling you the final result, but we tried many other things that didn't work. And the good thing is with this task is now it gives you perfect result of every aspect of attention, always give you a positive result. You measure always this aspect. We tried with other tasks, one component could not be measured or the other. So, but finally we got this version of the task, and in this task is very similar, like the one. In 60% of the trial, we have anti-trial. So basically, you have to respond to flankers, which can be congruent or incongruent for measuring cognitive control. These are previously preceded or not by a warning cue. By comparing these 2, you measure alertness. You are faster when there is a tone. Comparing tone with no tone trial, you measure alertness. And the visual cue sometimes appear at the location or the opposite location of the target. By comparing these 2, valid and invalid trial, you get a measure of orienting. However, we only have this 60% of the trial. In the 40% of the trial, you get either, all the trial adjust so that the total duration of each trial is 4 seconds and 100 milliseconds, but you don't know when things are going to appear because there's a variable interval at the beginning and at the end. Okay, the important thing is that on the other trial, in 20%, then you get the same thing, but importantly, the central arrow is displaced vertically. Before we tried with other things, displacement horizontally, it didn't work, and now after trying several things, that worked very well, and then people can detect this, and usually they start detecting 80%, cross-block, they end by detecting 68, 70%. So here, with those trials, we measure, these are typical, like the SART, and we measure executive vigilance with this trial. We have people have to detect the displacement in vertical displacement of this trial. Instead of responding to the direction of the arrow, they have to press spacebar for detecting a large displacement in the vertical dimension. And in another 20% of the trial, we have trials similar to the PVT. So basically, we have a number, big number in the center of the screen, starting 1,000, going down. And then you have to react as quickly as possible by hitting any key. And what's happened here is that, well, now we have done, when everything was finished, then we did a platform that you can access free, people can use for free for research. You can get data online or in the lab, and there is several tools there for analyzing the data, for sending a link so that participants don't have to enter the platform, simply clicking a link and receive the condition that you want to manipulate for this specific participant. Tomorrow I will have a seminar in which I will explain how to use it for research. I will give you an example. I will ask any question you have. So anybody wanting to come is welcome. And I will try to give you information so you can use, and I will give you, for example, some idea about how several experiments we are using the platform now or other people. Okay, and the good thing is the task gives you, as I said, an index about 30, 40 milliseconds for fasting alertness, orienting, executive control. This is comparing when the task is used in the lab or online. And basically, it's a significant difference, but in general, this difference is not that big because 30, 40 is not big difference, and probably because when people are in the online, they are more relaxed, and then they are more alert. Or they might be, we don't control the timing. Nobody's doing the task in the lab at 12 or 1 in the morning. But online, some people do whatever they want, so that could be. But in general, there's around 40 milliseconds is the average for the three indexes of fasting alertness, orienting, and executive control. And then you get a decrement in executive vigilance for both. So the hit rate, the number of times that you detect the vertical displacement is decreased across time. We have other indexes, but basically they go in the same direction, that you are less sensitive to the signal. And regarding arousal vigilance, both either the reaction time, the variability in the reaction time, the standard deviation, or the lapses. We define lapses in the ANTI-Vea of any responses as slower than 300 milliseconds. All of them decrease with time, increase with time, which means that you are less arousally vigilant. Okay? So we have the task that can be used for investigating vigilance. And now, for example, I'm going to explain you, I'm going to illustrate how we can use this task, for example, for explaining why it's difficult to maintain attention. This is a question that has been in psychology forever, like, why is it difficult? Because we could say, well, it's difficult. I mean, it shouldn't be difficult because paying attention is very good. We all agree that paying attention is good. So it should be good to maintain attention, pay attention for a long period of time. But why is it so difficult? People say, oh, you run out of resources, but what are the resources? If you eat a lot and you don't need anything, why you cannot be attending for 1 hour? Nobody understands. And actually, the usual theory that has been used is resource overload account. Well, you have a certain amount of resources, a quantity of attention. When you start spending your attention, and you run out of attention. And then you have no attention anymore. But that's like, what is this thing that is like gasoline? Like you have the tank full of gasoline, you start driving, and then there's one moment in which there is no more gasoline. But the brain doesn't work this way. Because the brain, when you are not attending, is also consuming resources. When you are not attending, the brain is in default mode. And the default mode is not that this stopped. The brain is all the brain areas, also consuming resources. So it doesn't work. And actually it doesn't work, but some people say, well, maybe the problem is not that you run out of resources, is that the mind, instead of going to pay attention to what you are doing, goes somewhere else. And it's mind wandering. So it's another theory. It's like, then it's not that you run out of, it's that the attention with the resources you have is paid to something else. You start thinking of what to do. You start thinking about what the hell am I doing? This is boring, all this and that. Withdraw attention from the task. And so reduce energy over time. Some people are very, very stubborn. Some people who really defend the resource theory, although there is a lot of evidence showing that this cannot be this way. But some people I put here because they said, well, it's too naive to say that resource theory think that these are non-renewable resource theory. Of course, resources can be renovated. But then if you can renovate resources, then what kind of explanation is this? We need to understand why you renovate the resources, why you allocate resources. At the end, the resource theory is not very useful, because then you have to explain the allocation of resources. And then motivation, mind wandering, there's a lot of things to explain. One theory that I like very much is the resource control account by Thompson, Bessner, and Smilek. What they say is that the amount of resources that you have is fixed across time. That makes sense. You know, in half an hour, in 1 hour, you don't run out of resources. If you have eaten well, drank water, enough water, you are sitting, you cannot run out of resources in 1 hour. So the question is that the resources that you have is okay, no problem, there's no decrease. What happened is that the equilibrium between the allocation of resources to the task that you are doing and to mind wandering, which is in white, that will change. So you start with an optimal allocation of resources to mind wandering, to the task, and mind wandering, you split. Depending on how you motivate it, you might have higher here or lower, but the thing, you start with an optimum equilibrium between mind wandering and resources. And across time on task, the cognitive control is decreased. What they say, you have less control. You need cognitive control because the mind tends to mind wander all the time. This is something that has to be explained why, but this is an assumption. We tend to mind wander. The mind go to mind wandering. You can control your mind and focus, but that's kind of difficult. That's what people do when they are doing mindfulness. They focus, they keep attention on the now, but that's effortful. But you can maintain attention, but cognitive control decreases with time. When you have less cognitive control, then attention go more and more to mind wandering. But then we have a very complex explanation, but well, we don't want a simple explanation. We want a correct explanation. And it might be that I think that with Vigilance, we have to go with this kind of explanation. Otherwise, we will not be able to explain. We have, for example, we have used the data from the ANTI-Vea task to test this hypothesis. It's very clear prediction. According to this theory, cognitive control decreases across time. And this decreasing across time will explain the decrement in Vigilance. So what we did, we took a database of 600 participants who did the ANTI-Vea, and we first tried to see whether cognitive control decreased across time. And then this is the congruency effect, interference. As you can see, across block, there is an increase in interference. An increase in interference means a decrease in cognitive control. The more cognitive control you have, the less the interference. So first, there is an increment in interference, a decrease in cognitive control. And there was a correlation between the decrement in control and the decrement in vigilance. The correlation is not very large, so it might not explain everything, but it's explaining something. If you take the people who have less decrement or no decrement in control, they had less decrement in vigilance. And the people who had more decrement in control, they have large decrement in vigilance. So it seems that we have some partial confirmation of this theory. Here we have a summary of some research we have carried out to distinguish between these two theories. Like, for example, by cognitive loading, asking participants to do a single, dual, or triple task, resources will make a very simple prediction. The more complex the task, when you have to do a triple task, you have to do 3 things at a time, that will consume more resources. And then the decrement should be larger. When you are doing something very easy, that will consume less resources. And that doesn't is not what you get. What you get is that in single and triple task, you get larger than in dual, or in other result, you get there's no difference. Clearly, the resource overload is not, when you manipulate the load of the task, doesn't confirm to prediction of the resource overload. It's more had to do with motivation or cognitive control. In another study, we compare exercise, so people were doing exercise while doing the task, or they ingested caffeine. And we found that the caffeine affected the resource overload, whereas exercise, physical exercise, affected vigilant decrement. So it looked like when we think of vigilant, we should think differently if we are thinking about arousal vigilance or executive vigilance. And in another case, for example, we did electrical stimulation, and we found that electrical stimulation, and you will see now, I will present the study more, affect executive vigilance, but not arousal vigilance. So one important thing is that when we're thinking in vigilance, we have to think differently in executive vigilance and arousal vigilance. And in fact, a more recent theory, the more recent theory of vigilance, actually consider both. So according to this theory, the optimal vigilant state will be when we have an intermediate arousal. Having too much arousal is not good, because then everything receives a lot of attention, the relevant and the irrelevant. When you have low arousal, then you don't do very well. It's good to have good, optimal, intermediate arousal, and then you get enough resources to attend, but not too much attention to be spilled to irrelevant information. And another thing is how this optimal level that I have, how is divided, depend on attentional control and motivation. So I had to decide what to do. Apparently I cannot, and that will be another talk to explain why I cannot dedicate all my resources to the relevant and completely block processing to the irrelevant. I mean, if you want, I can later, but I mean, basically, this is what we do. Human beings do that. I think that's very, very adaptable to the environment, but the best solution is not that I ignore completely anything else but what I want. Basically, because what I'm ignoring could be dangerous. So the best thing of attending is not attending perfectly. The best way of attending is attending in an equilibrium between dedicating resources to the relevant and somehow some resources being spread to the potentially relevant but irrelevant. But the thing is that we have arousal and control and motivation to split this resource, this capacity that we have. So that's why we need a complex task measuring everything in order to understand vigilance. Okay, and now I'm going to briefly tell you about two studies that we have done using the ANTI-Vea. One is the TDCS stimulation in the lab, and another is sleep deprivation study an online study. Okay, the TDCS study, we have done one study and replicated, and now we have finishing a third replication of this study. I wanted to have presented you the data, but we have not yet finished. But anyway, in the first study, we stimulated either parietal cortex, right parietal, or right right prefrontal dorsolateral cortex. And a participant, we first recorded EEG in the first block of trial. Then we have three groups. One received sham stimulation, which is that we only had the run up, it ran down at the end, but there was no stimulation through the task. Another group received parietal cortex stimulation, and the other one dorsolateral prefrontal cortex stimulation. They kept performing the task, and in the end, in the last block, the stimulation stopped, and we had an EEG recording because we wanted to see how TDCS affect both behavior and the EEG data. Okay? And first thing, here we have in green the sham stimulation, and in magenta we have the TDCS stimulation. As you can see, there was a decrement. This is the percentage of hit, the number of time, the proportion of time that they detected the displacement across a block of trials. And this percentage of hit decreases with time. When you stimulate, the group that were stimulated, no matter whether the stimulation was in the parietal or in the frontal, they did not decrease that much. So there was a palliative effect of brain stimulation on decrement of vigilance. But this was only for the executive vigilance. The arousal vigilance didn't change. All the group had a decrement in vigilance. And another important aspect was that here, in general, from the pre to the post session, in red is the first block, in blue is the last block. There was always, that's very typical, there's an increase in the power across all kind of waves, especially in alpha. There was an increase in alpha, but this decrease in alpha that was observed in the sham stimulation was not that increase in the parietal stimulation group. So when the stimulation was applied in the parietal cortex, there was no increase in alpha. So that's what we report in this study. And very recently, in a doctoral thesis by Clara Hemmerich, that Dr. Logeman was an external advisor, an external examiner of it, we replicated this pattern of data. We took only the parietal stimulation was the one that was successful in affecting both behavior and EEG data. Well, in this that was more or less the same. There was we took MRI because we want to accumulate data when we have enough participants to see to correlate the anisotropy of the white matter tract with different attentional function. But for this, you need long set of data. So we are accumulating, and in all these participants, also we acquire an MRI, T1, and DTI. But basically, the design was the same. In the first block, EEG, recording, and then starting the second block to the sixth, there was anodal or sham stimulation in the parietal cortex, and the last block, there was EEG recording. Again, we observed the same pattern of data. In the sham, we got a decrement in vigilance that was palliated somehow by the parietal stimulation. And no modulation over the arousal vigilant decrement. So there is a decrement in arousal vigilant, but stimulation in the parietal cortex doesn't affect it. And then regarding the EEG data, regarding alpha, well, we measure alpha, gamma, delta, gamma, and beta, but we got an effect of stimulation only in alpha and gamma. So in alpha, again, we got an increase in the parietal cortex, an increase in alpha power that was palliated by stimulation. So there was, you don't see here very well, but there is a reduction. This increase is significantly reduced compared to sham. So it's a decrease in the increment in alpha. And regarding gamma power, what you get is an increase, especially in frontal gamma. Frontal gamma is further increase in the stimulation group. So when you stimulate compared to sham, you have reduced increase in alpha and enhanced increase in gamma. So what we did, okay, maybe in order to be more sensitive, what you can do is to compute an index. And then we computed an index, which is the alpha parietal divided by gamma frontal. And then we got an index, and then we plot, or we investigated how this index changed from the beginning to the end. And then we found that from the first to the last block, in the sham group, there was an increase in this index because there was larger increase in parietal and reduced here. Whereas in the stimulation group, there was a decrement in its index because there was less increase in parietal and larger in the frontal gamma. So, and then we reanalyzed the data of the previous study, and that's the Luna et al. Study, and in this study. In this study, we didn't have any hypothesis for this when we collected, but we went back to the data and we found that exactly the same pattern was observed in both studies. And then we tried to find that actually this was correlated with the behavior. And if you split in two groups, the group that increased more from pre to post in this index, and the group who decreased more. And then what we found is that this is the pattern we had, but if we split in two groups, the group who have a decrease and the group who have an increase, so this group have a decrement, but not modulated by stimulation, but the group who have an increase in its index, then we had a large decrement in the group who received sham stimulation, but this decrement was completely eliminated by the stimulation. So it looked like the stimulation is effective, but might not be effective for everybody. So some people might be more needed of stimulation. Actually, in some of the studies I'm not going to present, we found that stimulation might be even not only not good, but bad for some people or task. So for example, if you are doing a task very simple, stimulation might be worse, might lead you to behave worse than, as far as we know, stimulation works with a difficult task for people who have difficulties doing the task, and that might help, okay? So, to summarize the study, we replicated finding that high density TDCS applied over the right parietal cortex lead to a mitigation in the executive vigilance, but not arousal vigilance. So, and also vigilance, the stimulation affect also the EEG, especially reduce the increment in alpha and enhance the increment in gamma. So it's important, that can be summarized with an index. We think that that might be useful, for example, for people using, for example, neurofeedback. They might use this index as the target in neurofeedback. Typically, people use like alpha divided by beta. So we wanted to explore whether this index might be more relevant than others. In general, this study highlights the relevance of using neuropsychological markers to further disentangle the efficacy of stimulation protocols. Okay, and then the last thing I'm going to present you is the sleep deprivation online study that we did. Here is a summary. It's a very complex study, but I mean, we were doing. I think I'm glad we did online, but we did online because it was we had planned to do it in the lab, but the COVID arrived, and then there was no other way of doing it. And we did online, but the thing is that by doing online, we said, well, that's very nice because that is very powerful. You can do an online study of sleep deprivation. So what we did, we selected 60 participants that were selected from a large population, only those meeting the criteria, for example, meeting intermediate chronotype. We didn't want people who can stay overnight and without problem. People in the middle range of the chronotype. Not taking drugs. I mean, there was a lot of inclusion and exclusion criteria. And then another thing is that we made a manipulation of motivation at 6 in the morning. At 6 in the morning, some group, they were paid, I think, about 80 euro for doing the study. 6 in the morning, they were given the possibility to win 10 more euro. That was the motivation. Some of them received that extra motivation. So basically, in the first day, typically on Monday, they will be connected online. Everybody will be connected. So they were doing the task and connected online. And we give instruction. There were several researchers controlling, monitoring, and they give instruction, everything. They start doing the task, and then we receive all the task. And then when they knew everything, they were appointed for the next day. Next day in the morning, in group, we did that in group of 20 people, between 15 and 20 people at the same time. The next day at 8 in the morning, they did for the first time the task. And we were monitoring that they were doing the task. And then, well, before doing the task, we measure emotional state, how difficult the task was, somnolence, activation with questionnaires. And then they will give an instruction and they receive a link for doing the task individually when they want it around 12, around 4, and around 8 in the afternoon. And they were appointed at midnight. Midnight, they went all connected with 3 researchers monitoring everything, and they started doing the task. And they were the whole night monitor with the iPhone, and they were doing the task in the computer. And we were monitoring if somebody was, we had the telephone calling them, hey, come on, what are you doing? We were also monitoring with the server. We were looking whether they were doing the task, and we were checking that they were doing properly. With this task, you know whether they are doing or not, because then you will not receive answers. So we were really monitoring. There was only 1 or 2 cases in which we had to call them and say, look, what happened? And they were getting asleep, and they went back. I mean, and there were only 1 or 2 people that didn't finish. So anyway, they were doing every 2 hours, they were doing the task. At 6 in the morning, we did the motivation manipulation. And 8 in the morning, they did for the last time. And then we left 1 day for washout. So, and then on Friday, 2 days after, they were cited again for doing the task fresh, after having slept the whole night for the last time. And then we can compare this one and this one as a baseline, okay, for different analysis. So this is more like the way we did. And everybody was at home, they were monitored, we were checking that they were doing exactly what we were doing. They were doing the task, as we have, I'm not gonna, the same task that I have explained before, measuring attention, or alerting, orienting, and aesthetic control, executive vigilance, and arousal vigilance. And we use the online platform. Okay, the result. First, regarding somnolence. And as we might expect, starting, this is the first day, and this is midnight. This is a baseline, is a mix of several, but it's the baseline. And then 2, 4, 6, and 8 in the morning. And this is when they are okay again later. As you can see, there is an increase in somnolence across the night. And there is no motivation, no effect of motivation, no modulation of motivation on somnolence. So if I give you more 10 euro, you are asleep the same. You cannot be non-sleepy by giving you 10 euro. The same happened with activation. Activation decreased and was recovered later, and there was no effect of motivation. What happened with the attentional function? Then in the anti-trial, reaction time. As you can see, reaction time increased along the night. You are slower and slower and slower, and there is some recovery by motivation. It can give you 10 euro, you can be a little bit faster. So even if you run out of resources, I give you 10 euro, and then you have more resources. So where does those resources come from? So the resource explanation alone doesn't explain. So it has to be something with motivation. Motivation is important. Regarding alertness, so alertness didn't change across the night. Orienting didn't change either, but cognitive control decreases. There is a decrease in cognitive control across night. So that's another important thing. Cognitive control, so you cannot be the whole night without sleeping if you have to do a task for which you need cognitive control. You cannot be driving. You cannot be doing tasks that require cognitive control. Regarding accuracy, more or less the same. Accuracy decreased along the night, and there was a big modulation by motivation. Motivation modulates that. You are better if you are more motivated. Here, alertness was also affected, probably because when you are less vigilant, you get more benefit from the alerting cue. So, but there was some probably indirect effect on alertness. There was no effect on orienting, and again, there was a decrement in cognitive control. There was less cognitive control, more interference, okay? So basically, we can see that basically we have a decrement. In general, you are slower, but you can palliate somehow that by motivation. You are less accurate, and you can palliate that. And you have less control across the night. What happened regarding vigilance? Regarding executive vigilance, as you can see, there is a decrement in the percentage of heat across night. There is a decrement, overall decrement across the night, and there is an effect on motivation. So even if you are doing worse and worse and worse, you are motivated and you can do a little bit better. You cannot do like the beginning of the night, but you can do, somehow you can palliate with motivation. Another thing is that we have within every single task, across blocks, we have a decrement. So you start doing the task and then you are doing worse and worse and worse. This decrement is increased across the night. So across the night, you do worse overall, and the decrement is steeper. So the decrement, I mean, you do worse, and you can stay for less time, focus. So it's a decrement in the decrement, okay? And the same happened with arousal vigilant. With arousal vigilant, you have an increase in reaction time. This increase is somehow palliated by motivation. There is a decrement within every single time you do the task. There's a decrement across time, across block of trials, and the decrement become more larger decrement across the night. So in summary, sleep deprivation leads to increase in somnolence and decreased activation, which is not motivated by motivation. Increased reaction time and decreased accuracy, which is mitigated by motivation. No effect on attentional orienting. There is an increased phasic alertness only in accuracy and decreased cognitive control with both reaction time and accuracy. And that fits with the literature, which have shown that mainly when they have used the ANT or anti-task or ANT-task, typically where is found the effect of sleep deprivation is an executive control. This fits with the literature, with this task, more or less the same result. Regarding the decrement, we get a decrement in executive vigilant, which is mitigated, and also the same with arousal vigilant. Arousal vigilant is decreased and mitigated by motivation. An important thing is here, because we got measure of everything, now we can test theories that use an explanation which cognitive control is related to motivation and so on. Here we found a much larger motivation. So the decrement in cognitive control is much larger across the night than across a single session. And now the correlation between the slope of the decrement in control correlate very highly with the slope of the decrement in executive vigilance. It's 0.5, which is very, I mean, I have checked many times because this is weird, finding that big correlations. And here, 0.7. The decrement across night in cognitive control, they correlate very highly with the decrement in arousal vigilance. So, just to some interim conclusion here, one thing is that it's successful. So for me, the fact that one such a study was possible to do, I think this is very important because that opened the door, for example, for doing sleep deprivation studies where participants are at home. You don't have to bring to the lab. You can test 10 participants at the same time, 20 participants at the same time. This, typical sleep deprivation is one by one, it takes for years. So you can do a study in 1 month. And people can be at home. And I mean, nowadays, we were thinking about the possibility of using some physiological measures. But now I think at the end, because we ran out of time, we decided to start. But now I think there is some different devices that you can use for measuring different psychological measures like heart rate or you could even doing online, but measuring all these measures as well. And the idea is that we found that the motivation mitigate, but not eliminate, some of the vigilant decrement. And there's the power of simultaneously measuring different components. This is a power of this task, that you can measure different things at the same time, And then you can look at the relationship, and then you can find how these variables relate, and then you can test the theories. Because the theories postulate some relation between different variables, but typically vigilance studies only measure one variable at the same time. Then it's difficult to test these theories. So then we can, this allow to measure the relationship between different components, like for example, executive decrement, arousal decrement, and decrement in cognitive control. We have tested in different, that these variables are related. The thing that we miss is a measure of mind wandering, because mind wandering is also very important. And many times people have told us, oh, why you don't include mind wandering? But I thought, well, what if I include mind wandering and then I lose all the other measures? So I was reluctant to use it. But you will see now we have a version in which we can add thought prof, and the task works perfectly. So next time, I would like to replicate this study with the new version of the task in which we also measure mind wandering. And now we are using the task with mind wandering thought prof to test these theories. But anyway, I would like to finish now with the conclusion. So basically, attention and vigilance for me is 3 attentional functions and 2 sources of control. This is the way I consider attention, taking the Posner and Corvetza's model, combination of them. I have shown you how the measurement of attention with the ANTI-Vea task can be successful in where you measure all these components and then look at the interaction between them. It is important to dissociate between arousal vigilance and executive vigilance because they theoretically make reference to different things and they might be modulated by different variables. The resource versus motivation control, this resource and motivation control account of vigilance, for me, is the theory that account better for vigilant decrement. And it's important that we add the distinction between arousal and executive vigilance to these theories. There is a specific effect of TDCS, whereas the sleep deprivation effect seems to be general. Sleep deprivation affects all kinds of vigilance, where stimulating the parietal cortex affects specifically executive vigilance. So they are different. It makes sense with sleep deprivation, when you have an overall reduction in arousal, then all the system is affected. We have using this task, the power of this task is that you can get large amount of data. For example, and then you can look at this data when you're looking for correlation, you need 200, 300, 400 participants. It's difficult to get this amount of participants one by one in the lab. So we have used, investigated with ADHD, people having ADHD symptom in adulthood or infanthood, which aspects of attention are affected, mindfulness trait, with Luis Cáceres, musical training. We have found that musical training, people who have musical training have better attention than those who don't have it, better vigilance. Recently, with somebody, Iva Wiwatowska from Warsaw, we have just under review on a study looking at trying to understand which are the attentional deficits in people who tend to procrastinate, and many other things can be done. A problem we might have is that, well, we lack a measure of mind wandering. And as I told you, this is what Julieta Aguirre is doing for her thesis in combination between the University of Granada and the University of Cordoba in Argentina. And we have now a version of the task in which we, from time to time, we put a probe and we tell them, where were your attention just before? On a scale from -1, meaning on task focus, to +1 being off task. And then when we can measure the proportion of time people were mind wandering, increase across block. And we tested in this first study with having 4, 8, or 12 because we didn't know how many. We thought maybe by having too many, then all the other measures goes away, and there was no differences. And the good thing is that with the thought probe, you have a measure of decrement, you have a measure of mind wandering, and all the other measures remain the same. So we could measure attention, vigilance, and mind wandering within the same task. That's it. Thank you very much for your vigilant attention.